Ding. All right. So you're filling a funnel at a rate of 30 pi inches cubed per minute. Let's say in part A, if the radius is 1/2 the height, write an expression for the volume of the water in terms of height at any instance if the water is draining at pi cubic inches per minute. Okay. So where do we start? Volume of a cone. If we just write down the volume of a cone formula, that's a great start. What is the volume of a cone? 1/3 pi r squared h, right? I said most of the time we don't have to do cones. I'm preparing you just in case you have a cone on a future thing. But you will not have a cone this afternoon. Okay? I'm just making a harder object, so then this afternoon maybe it'll be an easier object and an easier instance. This is not, I repeat, this is not the same problems as you will see this afternoon. However, they are similar. No, we're doing something very difficult, so then hopefully this afternoon is easier. All right. So, what are we told in A? The radius is what of the height? Half the height. So the volume equals 1/3 pi. Radius is half the height. How would I put that down? 1/2 h squared h. So really, the volume of this is 1/3 pi times 1/4 h squared h, or 1/12 pi h cubed. Okay. Now, what does this have to do with anything? That's how fast the water is going in, right? So that's a certain rate. So what do we do with rates on a problem like this? dV dt, right? Because the rate that it's going in is the volume divided by the time, correct? Okay. equals 3/12 h squared dh dt. Power rule, 3 from the h comes out front. So 30 pi should be equal to 1/4 pi h squared dh dt. Now, the height of it, we want the volume. It says, write an expression for the volume of the water in terms of height at any instance. So let's do some simplifying here. What can we simplify? The pi's cancel. Multiply by 4. 120 is equal to h squared dh dt. Don't want to lead you in the wrong direction. So I gotta just check the math factor. Oh, come on. Hey, I'm still recording. Still recording. That's a good sign. Good sign. All right. I'm just checking a fact here just to make sure in the Bible. I made this too complicated. This is part A. The volume at any time. The volume is 1/12 pi h cubed. But, yeah, express the rate as a volume in terms of height at any time. Okay? The volume, height, anytime. All right. So that is A. Now B might say, we aren't worried about the draining yet. We'll worry. Yeah. Don't worry about that yet. We won't worry about that yet. Because it's the volume of the height, and we'll get to that as we do later in the problem. I'll throw that in. You know what? We're going to erase that from part A. We're going to erase that from part A. And we'll just stop right there. Okay? There. Because we'll throw, because I was going to throw on the draining early, but that we should drain it later. All right. So then, at what height is, or I should say, how fast is the height changing? So it's not draining yet. When the height is 4 inches. How fast is the height changing? How fast is the height changing when the height is 4 inches? Okay? No, the initial is 0. So because it's a cone, you start at 0 and you start dumping water in, and at the bottom of the cone, it's going up fairly fast. But as you get wider, the height doesn't go up as fast because it's wider as you go up. Okay?
Yes. Am I wrong in saying you're asking the question is it gonna say when the height is 4 inches?
Yep.
So the derivative at 4.
When the height is 4, you're sticking it straight into there. Okay? So 120 equals 4 squared dH dt. So 120 equals 16 dH dt. Divide by 16. What's 120 divided by 16? Yes, this is a calculator problem. You get to use your calculators this afternoon. Yep. 7.5 inches per minute. 7.5 inches per minute. What should you do on this problem? You should label, because that sure might count you a point. Okay? Let's throw an easy thing at you. What is What is the height of the water when the height of the water is increasing at 6 inches per minute? What is the height of the water when the height of the water is increasing at 6 inches per minute? So then we go back to this that we solved for. So 120 equals h squared dH dt. We fill in for dH dt. What do we do? Divide by 6. We get 20 equals h squared, and then what is the height? 2 square root of 5, or decimal. What? 4.47 inches. Because it's h squared. Okay? All right. Should we be good with that? Okay.
What is the grading like?
What? There's like worth 18 points. It's like a quiz grade worth 18 points. So each part is worth 3 points. Actually, it's like 21 points.
Wait, how many problems is there on this?
2 problems. A car's velocity is 4 minus x squared to the third power. Okay? A. What is its acceleration at any time? Let's go t here. Four minus t squared cubed. What does acceleration do when you're dealing with velocity? The derivative. So you're taking v sub t equals 3 times negative 2t. Forgot the squared. Whoa, what was that? All right. So then it's negative 6t times 4 minus t squared. Squared. Okay? Okay. What is the equation of the tangent line of the velocity graph when the time equals 1 second? So, what'd you say? Because I.
The tangent minus the slope. So it's the derivative of velocity, which is acceleration. So acceleration at 1.
So the acceleration at 1 is what?
I didn't do that.
So if you put a 1 in, 4 minus 1 is 3. 3 squared is 9. 9 times negative 6. Negative 54. Okay. Then what do? That's just acceleration. What's the velocity at 1 second? Velocity at 1 second is 4 minus 1 squared cubed, right? Which is 3 cubed, which is 27. So it's basically the point 127 with a slope of negative 54. What's the equation? Y minus 27 equals negative 54 times x minus 1. So y equals negative 54x plus 54 plus 27. Y equals negative 54x plus 81. Okay, let's catch Maggie up.
Yeah, please.
I'm sorry. Maybe you should sit in your assigned seat. Okay, Maggie.
Yeah.
A tangent line uses a slope, which we find from finding the first derivative.
Yeah.
We found the first derivative in part A because the acceleration is the first derivative of velocity. Okay? We find the ordered pair for point slope form by, we were told 1 second, so that's the x value. And if we stick the x value into the velocity function, that is the y value. So we get an x and a y value and a slope. We plug it into point slope form and solve. So really, yeah, that we're good there. Find the displacement after 3 seconds. How would we find the displacement after 3 seconds? Integral of the velocity function, and our velocity function is 4 minus t squared cubed from 0 to 3 dt. Okay? Yeah. Now, Andrew Comas, because that's part of it. Andrew Comas said absolute value. That's the distance, not displacement. I thought I'd bring that up just to make it clear for everybody. Didn't want to call you out, Andrew, but, I did, and it's my bad for doing that. Now, if I tried to do this by hand, it would be a mess. That's why we're on the calculator section. Go. 30.771 and then it would be, ooh, I didn't give you meters or anything, but for a car? No. I think miles, yeah. Because let's say the velocity is in miles per hour. Okay? All right. All right. Yeah, generally on this test, you in this section, unless they say otherwise, generally it's about three decimal places.
It says in the instructions, the general instructions for section 2, unless otherwise specified, answers need not be simplified. If your answer is given as a decimal approximation, it should be correct for 3 decimal places.
There we go. Yep. Okay. Yeah, sound pretty verbatim to me. All right. This is yet another one, but let's say you have a function f of x equals 2x minus 5, g of x equals, this is different problem, okay? Different problem, equals, this should be 2x squared minus 5, maybe, yeah. And then let's go.
Oh, where's the cursor?
Reverse engineering.
So yeah, that's 60.
Okay. Okay, is this function continuous over all of our domain? Is it differentiable over all of our domain? How would we tell if it's continuous over our domain? You could graph it. You could set them equal to each other. Okay? But where is the point that we're most concerned with? 2. If I stick in a 2 up here, what is f of 2? 3. What is g of 2? Is it continuous? Yes. It's going to be continuous over all of our domain. Because this is a continuous, there's nothing to make this discontinuous, ever. Okay? And if we go from negative infinity to 2, a number will work no matter where you put it. This is a straight line. Is there anything that'll disrupt its continuity? No. And then, since they both meet at the same point, so we've got this going on. We've got something like this, and then like this, right? Okay, what is the first derivative at 2 for f of x? What is the first derivative at 2? 8. What is the first derivative of g at 2? Negative 1. Is it differentiable at all of them? No, because when these two have different derivatives, at this point, it'll make a point, right? And where it makes a point, it's not differentiable. It has to have the same derivative coming in as going out, basically. So that was that lesson about continuous and differentiable. Okay? So those are some of the things that you'll see this afternoon. Okay? I think everything this afternoon is fairly straightforward. It's not the exact same kind of questions, but it's, in the ballpark of those kind of questions. Now, do you have any other just general questions right now that we need to cover? It's going to be 2 problems. I'm going to give you a sheet of plain paper that you're going to write on, and then you'll get this. So then you just have to hand in your white sheet of paper, okay? You do not have to hand in the problems, okay? You do not have to hand in the problems. So you'll be given a white sheet of paper, any type of work you put on it. So you go 1, and then you go A, you do your work. B, you do your work. C, do your work, and give the answer. Then 2, A, do your work, and so on. Okay, plain sheet of paper. You can use your graphing calculators. Some problems, they'll be more important than others. Yeah. So these are not super duper difficult problems this afternoon. I gave you more of a basic one just to kind of get you going with this. Okay. All right. We literally have 10 minutes. Anything for the next 10 minutes? I'm going to stop the recording.